Yes, you. Are you trying to learn screw cutting by reading a book? Then you want to watch Tweed's Garage. Hello and welcome to Tweed's Garage, where in this video I'm going to talk about sort of screw cutting on the lathe. So this is just my sort of general experiences and what I've learned teaching myself screw cutting on the lathe. So this isn't for you experienced machinists out there and engineers of long standing. So if you'd like to leave now, the door is over there. Yeah, yeah, and you, yeah, thank you, yeah. All right, thanks, yeah, bye. Yeah, take Jenkins with you as well, if you will, because, yeah, he crashed the gearbox on the Bridgeport, so he's back to filing and fitting for next month, okay? All right? Right, they've gone. Okay, so this is just a little chitty chat to about sort of how I went about learning how to screw cut on the lathe. It took me a few years, about 20, to get the hang of it. It's not that it's difficult, it's just that you may not realise it. Maybe you've tempted it on an old lathe. I had a sort of Chinese sort of small lathe, but it wasn't very good. The half nuts were the first set of half nuts were cast, horrible Mazak type things, and they didn't even fit properly, so that didn't work. And then I replaced them with phosphor bronze bearings from another dealer in that type of machine, but they done bronze ones. That improved it, but you'd still get it, you get halfway through a thread and then the half nuts would disengage and you'd screw your thread up and you just sort of get disheartened and you give up. So I you know, like the rest of us, just got by using taps and dies, and we all know what they are. The trouble with taps and dies, it's okay if you sort of Johnny Frenchman, oh, vive le système métrique, with metric threads, you know, because there isn't such a range of them. But if you're sort of dealing in old British motorbikes, classic cars, vintage cars, you know, there's all sorts of threads out there, imperial threads especially. So to sort of have taps and dies in all those sizes, it gets quite costly. You know, you can sort of set out and buy sets in carbon steel, which will get you by most of the time in model engineering. If you're doing brass, mild steel, not a problem. But if you're starting to sort of cut tool steel or stainless steel, you know, the hardened steels, those tap and die sets won't last 5 minutes. So then you need to buy high-speed steel tap and die sets, and they are literally, you know, you can buy a carbon tap for about £3, and the equivalent in high-speed steel will cost you 15. So you can imagine the cost if you had to set that up in all the tap sizes. So the way to go around it is the lathe, screw cutting on the lathe, and it's the lathe's whole raison d'etre. That's why it's here. I mean, it's sort of originally taps and dies were turned up by hand by blacksmiths, so there was no standardisation to it at all until the Industrial Revolution and the lathe come along and sort of standardised it all. Yeah, and then the British took it and sort of developed millions of different types of standards to confuse everybody. But yeah, so if you've got a lathe, and you're not sure how to screw cut on it, this is just a little guide. And before the internet, I mean, I had to struggle through with books like this to try and get my head around it. This is a workshop practice series, which is a little sort of series of books we get in the UK that cover a lot of model engineering. But as you can see, it's quite, when you get to the front of it, there's a lot of formulas and numbers, and it all gets quite tedious actually. And yeah, if you're like me and can't do formulas, it's like a foreign language. So so then you sort of ask old retired engineers you know, or engineers that are still working, and the trouble is, it's like asking your parents when you have your first child for parenting advice. They don't remember, you know, it's just something they've done at the time automatically, and you forget it as quick as you can. And it's the same with sort of screw cutting. It becomes second nature to people that are in that business all the time. So they try and explain it to you, and they don't describe the bits that you need to know, because they know it and think you know it. So this hopefully will help those that are trying to get their head around it. Okay, so yeah, so screw cutting lathes, you get sort of two types. We get three types. You get your turning lathe, which is purely turning, tends to be some of the very old lathes, and some of the small mini desktop lathes and that, they won't have screw cutting facility on them. And then as you go up sort of mid-range, you get lathes like some of the old ones, like your Myfords and stuff like that. They sort of came originally as a screw cutting lathe, but you needed a set of change wheels that came with the lathe. And then what you do, you look at the plate. There's a plate on here, and if it didn't have a plate, you'd have to look in a book like this to find out what numbered gears you needed to go or in what order to give you the thread pitch that you wanted to cut. So then the next thing that come along is the holy grail of lathes, is one with a screw cutting gearbox, quick change screw cutting gearbox on it. So it's all built in. You very rarely, there are some gears you have to change sometimes, but very rarely, and for very special thread pitches that you probably never use. But for your majority of your standard threads, it's all done on the gearbox on the front. You just take your selections from your chart, dial it in, put it in, cut your thread, and off you go. So I'll show how to do it on this machine. This machine differs a little bit, but it's got an Angest screw cutting unit on the side, which is sort of for production work. It makes, if you're sort of producing something with a thread in the same place, and a lot of them, you set this up. There's a stop underneath you can set along the bottom of the bed, and that'll sort of what it'll do then is you'll bring in the half nuts. It will move across to where you want to get it to, and then once it gets to the stop, it clicks out the half nuts and stops. So all you got to do is wind the tool out and then wind it back to its start position, and then re-engage it again once you've dialed in your next cut, and off it goes and clonks out, and then backwards and forwards like that. Just makes it easy. I'll be doing it like that, but mostly if you've got a quick change gearbox on your lathe, or if you haven't and you're doing it with change wheels, you still engage the half nuts. This is done with this lever here on this lathe. Some are down here, so you'll know your lathe, or you've got a manual for it so you can work it out. So one bit of confusion that I was always getting when I was learning this, because it has got the Angest on it, it hasn't got the thread indicator on it, and this goes on here, mounts on here, and as the lead screw is running around, the numbers run around like that, and you'll normally have a table on the side, or in the instruction book it will tell you what sort of threads equate to the position on the dial that you need to wait for. So say it sort of tells you it's a 2, then what you do is you wait for as it's running around, you wait for the 2 to run round till it's just coming up to the 2. And this is the thing, people try and get it spot on to click it in, and get quite tense about it. But what you can do is you can lean gently on the handle as it's coming round, once it's gone past the last mark, once it's coming round to there, you can sort of lean a little bit of pressure on there, and then as soon as it comes round to the number that you need, it'll click in and off you go. Okay, so metric and imperial lathes have these. Now the confusion is, and I had it when I asked the salesman, they didn't know, on my first lathe, if it's an imperial lathe and you've got a thread indicator on it, it's only for imperial threads. Okay, and if it's a metric lathe, then it's only for metric threads. So yeah, just remember that. So if it's imperial, it's for the imperial threads. If it's for metric, it's for metric threads. This is imperial, so I'll be able to use it for imperial threads. If I was cutting metric threads on this, I have to engage the half nuts at the beginning of the screw cutting procedure. So you engage your half nuts, comes across, does your cut. So you stop it on the end of your cut and then wind the tool out, and you've stopped the machine. If it's got a brake, it's easy to stop it as well. If not, what you do is you sort of stop it, and because you're screw cutting, you're running at a low RPM, and it's probably got back gear on, so it's got quite a bit of momentum on it. So when you stop the machine, it will turn another sort of turn and a half to, you know, and you can gauge it and get it roughly to sort of stop roughly in the same place, and then pull the tool out, and then once it's all stopped, reverse your machine and then run it backwards, and then run the saddle back to where you started. You don't disengage the half nuts, you leave this all the time until your thread is done, and then stop it, then dial in your cut, set the machine off again, same again, go along, stop the machine just before the end of the thread, pull it out, reverse the machine, drive it back the other way, and then dial in your cut again, and off you go, backwards and forwards like that. So you do it. So on an imperial machine and you're cutting metric, always leave the half nuts engaged. If it's a metric machine and you're cutting an imperial thread, same thing. You do it on the half nuts, leave it engaged, get to the end, reverse the lathe back the other way, drive it out, and then backwards and forwards like that. Okay. Hope that clears out. That is a bit of a, you know, that can be a bit of a murky area. How you use these, you'll normally have a plate on the side of the machine that will tell you what threads equate to what numbers and what marks. So here we go. I haven't got a sticker on mine, but this is in the manual. Thread dialing indicator English, cut threads of even numbers per inch, close the lead screw nut on any line on the dial, and to cut threads of odd numbers per inch, close the nut and at any numbered line. So that'd be, that's a numbered line, and that's a, where are you? That's a numbered line, that's a not numbered line. Okay, so that'd be your odd number threads, and that'd be your even number threads for imperial. Okay, and as it says there, for metric cutting threads, dial cannot be used, lead screw nut must be closed and the machine reversed by the control lever after each pass and the tool withdrawn. See, it says it easier than I said it. So, and there it tells you if it's a metric machine, how you use the indicator there. I'll just be using high-speed steel tool ground up to cut the threads. And these are fairly simple. There's a little bit of rake on top, but you don't need rake on the top. It's more like a parting off tool, sort of flat rake on the top. And then the way you do it is you get one of these little thread guide plates like this, and it's got the 55-degree angle for your imperial and your 60-degree angle for your metric and your American SAE threads. Okay, so you just use that as a grinding guide. You know, sort of hold it up to your tool as you're grinding like that. Hold it up above a bit of white card so you can see, and just sort of grind it away to get the right angle. Okay, I've got one in here that is ready to go, and that's imperial because I'm cutting a thread, an imperial thread, 3/8 20 pitch, which I measured with my thread gauges. I've shown you these before. You know, little combs like that goes in your thread. So which is a BSF 3/8 thread. So that's what we're going to be cutting on the lathe. So the first thing they tell you to do is set your tool slide over to half the angle of the thread you're cutting. So for metric it would be 30 degrees, but you don't set it to 30 degrees. This is what they don't tell you. You set it to 29, and if it's imperial, which is 55, it's 27.5, so about 27, 26.5. It's not critical. Don't get wound up about it. You've got your your markings on the bottom of your tool slide. Get it round to approximately just under half the angle. So for a metric, 29-ish. For imperial, 26.5, 26. Okay, doesn't matter. So the main thing, via the magic of Whiteboard, I'll show you why. So this is why you set your tool over to half the angle of the thread you were cutting. If you didn't, and you're just plunge feeding the tool straight into the job, it will be cutting along two edges. It'll be cutting along this edge and along that edge, putting a lot of loading on it. You can get away with it on very fine threads, very close pitch threads. You could get away with it. It wouldn't really be an issue. But once your threads get coarser and deeper, then the loadings will get more on the tool. So what you do is you set the tool post over at an angle and the thread tool like that. So when you feed in, it feeds it into the job, but also slightly to the left, so over to this side, so that when the next cut comes in, it won't be cutting on this side. It'll be free on this side, but cutting into the job here. So it will then be cutting just around the nose a bit and along this edge here. Just draw it in quickly, it's all coming out there like that. Okay, so that's why you set it over. So every time it moves in and across this way, cutting in that way, moving deeper and still creating the V you want for the slot. So there you go. See, it's all about tool loading. So you want to sort of cut down on the loading on the tool because you're doing a plunge cut. It load like parting off. It loads the tool up. So you want to minimise that. So set this over, and as it's imperial, setting it to sort of 26.5 degrees. So the first thing to do on your part is you've turned it down to size, the size of the thread. Next thing to do is put a chamfer on the end to allow your cutting tool to come in easy without banging up against a hard shoulder. You can either do it by turning the cross slide and turning a taper on the end of it, or the easiest way is just run a file over the end to put a nice little chamfered edge on. So with the tool slide set over, the next thing to do is just use your thread gauge again, just to set your tool up and make sure it's square to the job that you're cutting the thread on. So you just line it up like that until it lines up, and then tighten down your tool post and you're ready to go. Because I'm using the Angest screw cutting attachment on my lathe and it stops automatically, it always stops in the same place that you set it. So you don't need to worry, the tool will just run a nice little groove at the end. But if you're running it on the half nut lever, you'll be knocking it out when it gets to roughly where you want it, but you won't get it in the same place every time. So what you want to do before you start cutting your thread is, with a parting off tool or a sort of half round tool, is to turn a little recess behind the end of the thread for your tool to run out into. rather than it keep stopping in different places and you're getting sort of, you know, untidy grooves all the way around. Okay, and then what you do is you turn that down to just below the depth of thread that you're cutting. Okay, and how do you know the depth of thread? Because of the old book or on the charts. If you have a look on the charts on here, we're doing the 3/8 depth of thread 0.0320 of an inch. So as long as it's sort of there or a little bit deeper than that, it will be fine. So I set up an indicator on the back of the tool post so that I can keep an eye on my depth of cut. Trouble is, because you've set it over at an angle, the dials aren't a true representation of the cut that you're taking because it's set over. And then sort of, you know, the engineers and machines say, oh, you just work it out by sines and cosines and all that. But, you know, that gets complicated. So the easiest way is put a dial indicator behind, and because it's resting in line with your tool post, the direction it's moving, that way it will give you the correct depth of cut. So to set the machine up for screw cutting, you just follow your plate that you've got on your lathe or your manual. So on this one we're cutting an imperial, so it's 1 inch threads, or threads per inch. This side it's millimeters, so this is the one we want, and we're cutting a 20 pitch thread, which is there, and it's asking for L, which is low gearing, which is set in here. I haven't touched that. There are some high ones you need to do, but at the moment it's set for L for low. So they're the only gears on this machine you need to change over. And then where we go, LB, this lever here, B, so you set that to B, 3 on the stick there, and then S on this lever here, and in this box here, V, which is on this one. Okay, so that's all set now for 20 threads per inch. Speed setting doesn't make any difference. It's all through gearing that gives you your thread pitch. Okay, and then what you want to be doing is cutting as slow a speed as you can. Normally, you know, you set it. I mean, this lathe is lovely. It goes really low, but you want to go as slow as you're comfortable with. You know, if you're going too fast, you panic, you might not draw the tool out quick enough, you might crash the tool into the chuck. Easily done, and especially if you've got back gear, that's when you can cause the damage, because there's so much power going through the gearing, you can cause damage. Okay, because I've got the Angest, I can run it a little bit faster. Well, I can run it really fast, but so we can see what it's doing, run it about 170. So let's do a scratch pass to measure our thread and zero all our reading. So we just check it with the thread gauges to make sure it corresponds to the thread we want, because it's easy to make a mistake on the levers or the gears. So you've done your scratch pass and you've zeroed your dial indicator, and you zero back your DRO, getting ready for your cuts. So what they sometimes don't explain, they sort of brush over it really quickly. This is your home position. Yeah, so when you knock out your half nuts, you unwind the cross slide out. You don't touch this one. This is your cut depth, so you leave that as it is. You use this to withdraw the tool out, go back to your home position. You then wind this back to zero, and then you clock in your next cut depth on the tool slide. You know, you use your dial indicator to guide you. If you haven't got a DRO to do the home position, you can either remember you know, that you set this to 0, but sometimes you can get carried away in the heat of screw cutting and wind this out and forget how many winds you've brought it out. So the other thing to do is to put a dial indicator on the back of the cross slide to give you your home 0 position for the cross slide. So with the tool slide 0 back to its home position, or cross slide, sorry, and then we'll dial in the first cut, and then we'll set it on its way. First cut, and set it back, its next cut. And you just keep going. Move it back to 0. Dial in my cut. Set it on its way. Move the tool out, move it back to home position, cross slide back to 0. Go to the dial indicator you'll be watching here, and dial in your next feed, a cut. I'm doing about 3 thou at a time, and I'll gradually get less as I get deeper in. Set it on its way. If you're using the half nuts, you'd have your hand on here, and then when you get to it, you'd knock it out and pull it out. The only difference is this is automatic, so I don't need to knock it out. Back to your start position. 0 your cross slide. Dial in your depth of cut. If you add an indicator, be waiting for your number to come round. Lock it on, send it on its way. Cross slide, dial in the depth of cut, and send it on its way. When you're first starting off, it's handy to have a, if you're cutting a bolt, make sure you've got a nut handy, and if you're cutting a nut, make sure you've got a bolt handy. But the magic with the lathe is you're cutting threads sometimes for items that you either haven't got or they're sort of on the car. So you just have to sort of trial and error. This is why you need, it's handy to have this so you know the depth of cut. So at least you can do your depth of cut on here and know you're within the ballpark. Okay, so let's get this one finished. So there we go, got to a depth of cut. We've got our trial nut to go on. And that goes on quite nice. And then all we need to do is just run a file over the top of the threads just to round them off slightly. And there we go, thread cut on the lathe in stainless steel. And if you've ever tried to cut thread on stainless steel with hand dies, you know how tricky it is. So there you go, a perfectly acceptable 3/8 BSF thread cut on the lathe in stainless steel. Once you've cut one or two threads and you start getting the hang of it, you'll start wondering why you ever struggled with it. But yeah, I hope there were some little pointers in the video that helped. So there you go, that's my tuppence worth of advice on screw cutting on the lathe. And once you start doing external threads, then you can move on to internal threads. It's all the same process. It's just that if you haven't got this sort of facility on the lathe and you're relying on knocking the half nuts out, if you're doing internal threads all the way through, not a problem, you can do it the same way. If you're going into a blind hole like these studs that I made, what you'd need to do is, I mean, you grind up a tool like a boring bar with a little tip out the side of it to the profile of the thread you're cutting. But what you probably want to do with that is set your tool into the work upside down, the tool mounted upside down, and run the lathe backwards so that the tool cuts on the way out. Yeah, but if it's a through hole, not a problem. But if it's a blind hole, then you've got to take a little bit more care. But once you get the hang of it, yeah, the world's your oyster, as they say. Okay, so if you found that helpful, give us a little like, and if you want to see more of this nonsense, subscribe, and what they say, hit the bell icon as well, and I'll see you next time. All right, cheerio. Come on your bed. Oh gosh, the other one. Cutting forces will be Billy. Lou, leave him alone. Oh, for God's sake. Hello. Mind your head. Come on, down you get. Down you get. Oh.